I'm Anil Kumar. Welcome to my series on inequalities. Now let's take up polynomial inequalities. Here we have 6 examples. I'd like you to pause the video, copy these examples, try them out. These are from previous test papers, so I hope you find them very interesting. So we'll move on straight with their solutions one by one. The very first one here is inequality, which involves two quadratic functions on either side of greater than equal to. So the idea here is to bring them to one side. That is the first step. So let's do that. So we have x squared plus 7x plus 25. Bringing these terms here gives us plus x squared plus 10x plus 10 greater than equal to 0. Now combine the like terms, so x squared becomes 2x squared. 7x and 10x gives us plus 17x. 25 plus 10 is 35. Greater than equal to 0. Now we need to factor them. Looking for here is a product of 35 times 2. So we're looking for two numbers. Let me write down here P and Q, whose product is 35 times 2, which is 70. And if you add them, you should get a 17 as their sum. So what could be these two numbers? So you need to figure this out now. So 17. So the numbers could be, whenever there are big numbers to work with, the idea is to do prime factorization. So 70 could be written as, for example, 10 times 7, right? 10 could be written as 5 times 2. Now, when you multiply all these numbers, you do get what we need, but we need combination which will give us sum as 17. That's the whole idea, right? So 10 and 7 can give us, right? 10 and 7. So right there we have this combination. So we will split 17x as 10 plus 7. So I could write this as 2x squared plus 10x plus 7x plus 35 is greater than equal to 0. Now factor 2x from the first two terms. You get x plus 5. And here you could factor 7. So you get x plus 5. Now x plus 5 is a common factor. And the other one is 2x plus 7 greater than equal to 0. Now at this stage you can make table of values and then solve the inequalities. That's one way of doing it. But for this I will sketch a graph. So we'll actually at this stage we'll sketch graph to find. That is much faster way. So let's see how. So I'll just make a very rough sketch here. So on a number line, then let's this be x-axis. We have two zeros, one at minus 5, the other one is at minus 7 over 2, which is 3.5, right? So both our zeros are at, so let's write down zeros here. 0 is at x equals to minus 5. And here the 0 is at x equals to minus 3.5. Correct? Now this is a parabola which opens upwards. Correct? So what you could do is you just approximately just sketch a parabola. We know two x-intercepts being on the negative x-axis side. So that gives you those 2 points. And clearly from here you get your solution. Means you're looking greater than equal to 0 means you're looking for a positive value. Is it okay? So it is positive in this side. These 2 points for you are minus 5 and minus 3.5. Correct? So from here you get your solution. So let me write down the answer clearly. It is from negative infinity to negative 5. We cannot include infinity, but we can include this 0 since it is greater than equal to, right? Union the other side, which is including minus 3.5 and goes up to infinity. Do you see that? So that is how we get the solution of the very first inequality. So I hope the steps are absolutely clear. Now let's move on and find the solution for the others. Now this is an excellent example. We have x squared plus 2x whole square minus 4 times x squared plus 2x plus 3. Now to make it much simpler, I'll make a substitution. Let p be equals to x squared plus 2x, right? In that case, I could write this as p squared minus 4p plus 3 less than equal to 0, correct? Now that becomes a quadratic equation in p, which I could actually write as, we are now looking for product of 3, sum of minus 4, so minus 3 and minus 1 can work. So we could write this as p minus 3 times p minus 1. Does make sense to you? Well, p is x squared plus 2x. Let me replace it back. So what we get here is x squared plus 2x minus 3. And here we get x squared plus 2x minus 1 less than equal to 0. Right? So we replaced back p as this. Now for some of you that may not be required, but just for clarity I've shown it. So we now get quadratic functions which can now be further factored, right? Or you could find zeros for these. Now this one, minus 3 means 3 times 1, 3 being positive. So we could write this as x plus 3 times x minus 1. Now here we need a product of minus 1, but the sum is plus 2, so you cannot really do it. So to find the roots of this one, we need to apply the quadratic formula, right? So let's do that on the right side. So sometimes there is a lot of work involved. Okay, so the quadratic formula I hope you're familiar with. So x, we are trying to solve roots for this one, equals to minus of b, which is minus 2 plus minus b square is 4 minus 4 is c, so that gives you plus 4, right? 4 times minus 1 divided by 2 times a, which is 2, right? So this is what you get, that is minus 2 plus minus 8 square root is 2 square root 2 over 2. So what we get here is x equals to, when you divide by 2, you get minus 1 plus minus square root 2. So those are the two roots for you. Okay, so we are landed with these 4 roots. Now 1.41, let's say approximate value. So I'm just trying to figure out these two roots, which are at approximately, minus 1 plus 1.41 and minus 1 minus 1.41. Is it okay? So that gives you approximately 0.41, say 0.4. We're just trying to figure out where it is on the number line. And here it is minus 2.4, let us say, okay. So that gives you 3 roots, correct? So I'll use these approximate values, okay? So we'll write this value as x minus, this is 0.41 times x, that becomes plus 2.4, correct? Less than equals to 0. So we have zeros, 4 zeros here. Of course, zeros are at x equals to, this is minus 3, this is at 1, this is at 0.41, this is at minus 2.4, right? The exact values is minus 1 plus minus square root 2. Now if I have to sketch this, so we'll solve all these questions by sketching. You could make table of values to figure the solution out, right? So polynomial sketching. So what I'd like you to review for this exercise is also how to sketch polynomials. So I'm not using table of values, correct? So we have 4 zeros, one at, let's say this is at minus 3, this is at minus 2.4, and then we had at 1, and let's say this is at 0.4, right? So 0.4. Okay. Leading coefficient is positive, right side up. All are linear zeros, right? So these are the 4 zeros for us. So if you sketch the graph, what do you get? So let's do the sketching part now. So right side is up, both are up, degree 4. Okay. So we'll go like a linear function like this, right? Like this. Okay, that's it. We're looking for less than. That means we're looking for a solution where it is negative, right? Including zeros. So we get that as our solution. Perfect. So now we know the solution is between -3 and that part. So -3, and this is -2.4. Let me write down the exact value. -1 minus square root 2. Both included. Do you see that? Union. Now from here we have the other value, which is -1 plus square root 2. It's always good to write the exact answer. We took these decimal values only to find their position with respect to others. Okay, and 1. So that becomes the solution, correct? Note. Try with table of intervals, right? So I'll provide you a link on how to do it with tables, but this is sketching is a nice way. We're kind of promoting that in this particular video. I hope that helps. Now here we have double inequality, right? So we'll call them double inequality. So this one is double linear inequality. Let's see how to solve them. So let me rewrite the question, which is 4 minus 3x is less than 9 minus 5x, which is less than minus 3x minus 3. So first step is we can add 3x to all. So we'll do 4 minus 3x plus 3 plus 3x. And then we have 9 minus 5x plus 3x. We are adding 3x to all of them. So we have minus 3x minus 3 plus 3x. So once you do that, you get numbers on either end. So this is 9 minus 2x is less than, so here we get just minus 3. Now we have to get rid of 9. So we'll do 4 minus 9. 9 minus 2x minus 9. See the steps involved. 4 minus 9 is minus 5. Here we get minus 2x. And here we get minus 12. Now what we need to do is divide by minus 2. You get an idea. Divide by minus 2. So this is a very critical step. We need to divide by minus 2. So when you divide by minus 2, the signs change. So these signs will change since we are going to divide by minus 2. You get an idea, right? So that's a very critical step. Here, of course, we'll get x. Dividing by minus 2 gives us plus 6. Dividing by minus 2, it becomes positive 2.5. Correct? So we are saying x is greater than 6, but 2.5 is greater than x. That is what we are saying. Well, that is not possible. And so we have no solution. So do you understand? X cannot be greater than 6 and less than 2.5. That's why in this case we have no solution, right? So make a note of this. Many times you may not have solution for a given question, right? That's the correct solution. Now here is another inequality. So polynomial inequality. X to the power 4 minus 2x cubed plus x minus 2 is greater than 0. Let's factor. Now let me rewrite this question. X to the power 4 minus 2x cubed plus x minus 2 is greater than 0. So we can take x cubed common. We get x minus 2 plus we already have x minus 2 here is greater than 0. X minus 2 is common now. We get x cubed plus 1 greater than 0. Well, you could factor x cubed plus 1, you get x minus 2. Here we get x plus 1 times x squared minus x plus 1 greater than 0. Now that gives you two real zeros, right? So now we have real zeros which are at x equals to 2 and at x equals to minus 1, right? So now we will apply a different method, which is we'll do inequality solving with table of values and intervals. Now this is another method. So what we do here is, looking into zeros, we know only at zeros the graph can change the sign. So we'll analyze the intervals which are formed because of these zeros. So here is a table. So we'll first write our zeros. Now zeros are at x equals to 2 and x equals to minus 1. So let's say this is at minus 1 and this one is at 2. So these are our zeros. Now these zeros divide the interval into, the plane into three intervals. So this divides the plane in from minus infinity to minus 1. This is minus 1 to 2. And here it is 2 to infinity. So we are going to take test points in these intervals, right? So the test point here could be minus 2. Test point here could be 0, and we could take 3 as our test point here. Now we have so many other factors. So let's write down these factors. We have a factor which is x plus 1. Then we have a factor which is x minus 2. And then the third factor which is x squared minus x plus 1. So substitute this value and check whether it's positive or negative. So if I substitute minus 2, I get negative. 0 gives me positive. 3 will give me positive. In this case, if I substitute minus 2, negative, negative, this is positive. Here, if I substitute negative 2, I get 4 positive minus 2. So it is positive. And we notice that it is positive for all the values, right? So it's positive for all the values. Since the sign only changes at the zeros, this is not a 0. It is not going to affect it. But when you multiply two negatives, you get a positive. One negative is a negative. All positive is a positive. We are looking for greater than 0. That means we are looking for a solution which is positive. So in our case, the solution is right there. Zeros are not included. Do you see that? Zeros are not included. So that is the interval method using table. Correct? So we write down our solution here is as an answer. So it is from minus infinity to minus 1 union from 2 to infinity. Correct? See, 0 is not a part of solution. If I substitute 0 here, I get minus 2 greater than 0, which is not true. It is not a part of solution. Do you agree? Right? If I write a very large value, I know this is very large positive. That is a part of solution. Correct? So that gives you the solution and also a check. So I hope this method is absolutely clear. Right? So first few examples we did with the help of graph. This is with interval notation. Make a note of this as a very standard and important method to follow. Okay, the next example here is a cubic function. So we have x to the power of 4 plus x cubed minus 2x squared less than 0. So we can take x squared common and we get x to the square plus x minus 2 less than 0. So product of minus 2 sum 1. So it could be factored as x plus 2 times x minus 1 less than 0. You have to be good at factoring. Now let's again sketch it. I'd like you to pause the video, sketch this particular graph, right, and then check my solution. Okay. So we have how many zeros this time? This is a 0 right there at the center is order 2. Then we have a 0 at minus 2 and we have a 0 at plus 1. End behavior is both side up, right? Both side up. Now, Multiplicity. This multiplicity is 2, so it is turning. This is 1, linear, linear. You get my idea. So the graph turns here. Okay. Now you need to sketch the graph. So here is the graph for it. So it goes kind of like this, turns here. And the solution is the part which is negative. So we have this as our solution, right? Not including 0, correct? So from here, we do get our solution, which is our answer, and which is from -2 to 0, not including both the zeros, union 0 to 1. Does make sense to you? So follow this method. Graphing gives you very quick solution. Table of values is must to know. At times you may have to do it using table of values. Now here we have taken linear double inequality once again, right? So the question for you is 2x is less than 3x plus 6 over 2, which is less than equal to 4 plus 2x. So you'll note that this is less than sign. Here we have less than equal to sign. I'd like you to pause the video and solve it. So first step here will be times to both sides, all sides, I should say, all sides, right? Since we want to get rid of fractions, so if I multiply by 2, I will write this as 4x is less than 3x plus 6, which is less than equal to 8 plus 4x. Now we should get rid of 4x, correct? So we'll do 4x minus 4x, 3x plus 6 minus 4x, 8 plus 4x minus 4x. Now that gives you 0. Here we have 6 minus x, and here we have 8. Now we could add minus 6, so we get minus 6 . Now, we need to multiply by negative. We have to change the sign. But let me rewrite this once again. We get this as 2. So when I multiply, important step, with negative, the sign changes. Do you see that part? Negative becomes positive 6, and this becomes negative 2. Does it make sense? Yes, it does. Now at times you may be required to show the solution on a number line. So this time we'll show the solution on a number line. So what we have here is that the value of x is between 6 and -2, where -2 is included. So right side of -2, right? So -2 is right there, and since it is including, I'm filling it up, and it goes up to 6, where 6 is not included. You get the idea, right? Somewhere here is 0. So that becomes the solution on a number line, right? So you could write as just given here, or you could say -2 to 6. So that brings us to the end of the video. I hope you have learned different techniques to find solution for polynomial inequalities. So let's go back and review them one by one. So in this particular video, you learned how to write solution on a number line. You also learned how to solve double linear inequality. Remember, whenever we multiply by a negative term, like this here, the sign direction also changes. That's a note, right? So keep a note of this. The questions which we solved in this particular video includes this set of questions. So these 6 questions are very good questions from previous test papers, which will help you review polynomial inequalities. In the reverse order, we had degree 4 inequality, which we factored and then solved using a graph as shown here. This is always the fastest way of solving polynomial inequalities. You may have to review graphing techniques for polynomials. We also showed you how to solve inequalities using table of values. Every 0 will divide the plane into number of zeros plus 1 intervals. You could have a test point and test whether the function is positive or negative on either side of the zero, as the graph of the function can change sign only around zeros, right? Sometimes we may not have any solution for the inequality as shown in this particular double inequality, right? So no solution is at times the right solution. Then again, we factored degree 4 equation, where we use substitution to write it as a quadratic function first and then use the graph to factor. To begin with, we had quadratic functions on either side with greater than equal to sign, and you saw how easy it is to solve polynomial inequalities, especially if you could sketch a graph. So that's the fastest way of doing it. I recommend you to practice some more questions from your textbook so that you're absolutely ready for your own test. If you feel good about my videos and if you like them, that'd be great. You can always share them with your friends, subscribe them. Thank you and all the best.